Hi everybody, and today we will be wrapping up the last section of chapter 4, and we're going to use hopefully some practical applications of exponential functions and all the work we've been doing with those. So we know we've looked at some models where things change linearly. Now we're going to look at some cases where things change exponentially. And the difference, of course, is with linearly is you increase by the same amount over per unit time, whereas here with exponentially things are increasing or decreasing by a factor. So rather than adding the same amount each time, you're multiplying by the same amount each time. Okay, so that's what we mean with exponential functions. So in this case, this first example, we have a rumor that spreads that celebrity X is dating celebrity Y. Now, we're not going to worry about who X and Y are or what we mean by dating, but we're just going to focus on the rate at which the rumor is spreading. And suppose as of today, 25 people have heard of this rumor, and this number triples each day. That is, the number of people who have heard the rumor triples each day. And if we let that number be a function of t, that is, if we let f of t be the number of people who have heard the rumor, both past and present, t days from today. Okay, so obviously f of t is going to be a number that increases. And it's increasing exponentially by a factor of 3, because it says triples each day. Alright, so the question is, what would be the formula for that? Well, let's just look at a few values. So we know that f of 0 is 25. F of 1 would be 3 times 25, that would be 75. F of 2 would be 3 times this, so this would actually be 3 times 25, or 3 squared times 25. And we can check that that's 225. And then if we do one more, f of 3, this would be 3 times this, so this would be 3 times this, that would be 3 times 3 squared times 25, or 3 cubed times 25, which I guess is 675. Okay, now, the reason why I did these intermediate steps is hopefully you can see the pattern here. Here we have f of 1 is 3 to the first times 25, f of 2 is 3 squared times 25, f of 3 is 3 cubed times 25, right? So hopefully you can see what the pattern is, that f of t is going to be 25 times a power of 3. 3, in this case, 3 to the t. So that would be, that's the formula for f of t. And then once we know that, then we can easily find the second part of the question. How many people will have heard 5 days from now, or maybe 12 days from now? So 5 days from now, f of 5 would be 25 times 3 to the 5th, which on our calculator we can get to be, let's see, well, what is that? I did not do this in advance, so I'll do that right now. So we have 25 times 3 to the 5th is 6,075. And then 12 days from now, f of 12, that would be 25 times 3 to the 12th. So that turns out to be 13,286,025. Okay, so that's how many people will have heard after 12 days. So you can see that when things increase exponentially, they increase very, very fast. Let's do another example. This one feature money matters. Then, so you can't really make much money from depositing money in the bank, but you can make a lot of money by investing in the stock market. And suppose you invest $2,000 in the stock market, and it doubles in value every 6 years, which doesn't always happen, but we'll assume just for this case it does. And we let A of t be the value of your investment t years from now. Okay, so let's say we wanted to find a formula for A of t. Well, once again, we can sort of see the pattern. So A of 0 initially is 2,000. We can say A of 6 is double that, so that would be 2 times 2,000, so that would be 4,000. Now, we could plug in some numbers for, well, we can't really plug in any other numbers because right now we don't have any other data, other than the fact that we obviously, this is going things when things investments grow exponentially, not linearly. So based on that, we know that A of t is going to be in the form of little a times b to the t. So remember, every exponential function is going to be in this form. Sometimes instead of a t, we might have an x or some other variable. But basically, it's constant times another constant raised to a variable. And this is actually enough to figure out what a and b are, because when a of 0, when t equals 0, we get 2,000 equals a times b to the 0. Okay, so b to the 0, of course, is 1. So 2,000 is equal to a. And then when t equals 6, we get 4,000 equals a, which we now know is 2,000, times b to the 6th. Okay. Well, we can divide both sides by 2,000. So these cancel, and this becomes 2, and this becomes b to the 6th. Okay, so how do we solve this exponential equation? We just basically take the 6th root of both sides, or we can raise both, that is, we raise both sides to the 1/6 power. Okay, which we can do, and because 6 times 1/6 is 1, so we get 2 to the 1/6 is equal to b. And then to figure out what b is, we have to use our calculator. And when you use that, make sure you use the inner 1/6. Don't give if you're going to give a decimal approximation of 1/6, that's, you need more than 1 or 2 decimal places. So the easiest way is just to type in 2 to the 1/6 in your calculator. And so b turns out to be approximately 1.122. Okay. Now, you might want to be more accurate. You can use more decimal places. Okay, but we'll see. So when you're doing your homework, make sure you pay attention to see how many decimal places you want. And because that's if they say 3 decimal places for your final answer, well, in this case, I guess you want two decimal places, but we want to have as many digits. So feel free to add more digits here. But some of the problems will just ask you what is a, what is b. So anyway, it turns out that a of t, the capital A of t, is going to be 2,000 times 1.122 raised to the t power. Okay. And so if you wanted to figure out what is the value of your investment in 10 years, you just plug in t equals 10. That would be a of 10, should be 2,000 times 1.122 raised to the 10th, which is approximately 6,323 and 52 cents. Now, of course, if you have more digits here, you're going to get a slightly different answer. Okay, if you if you do this with 1.1225 to the 10th, this turns out to be 6351.75. Okay, so the more digits you have, the more accurate your final answer will be. Okay, so we'll do some more examples in the next video. See you.